Question 1. The efficiency of a modern natural gas power station is approximately, the answer to this is B, 50%. Natural gas power stations are the most efficient in comparison to oil or coal, and you will seldom get anywhere in this region for efficiency. There's always a lot of energy loss in that process. Question 2. The energy source that currently provides the greatest proportion of the world's total energy demand is, and that is B, oil. Again, that is something that you need to know, something that you need to learn from your textbook and so forth. Question 3. In a nuclear power station, uranium is used as the energy source and plutonium-239 is produced. Which of the following is true? Now, let's just go through these. Plutonium-239 is produced by nuclear fusion. This is fission, so that's not correct. A moderator is used to absorb the plutonium-239. No, the moderator is used to absorb the neutrons. Not to absorb them, but to slow down the neutrons. Control rods are used to slow down the plutonium-239. No, the control rods are used to slow down and to absorb the neutrons. And plutonium-239 can be used as a fuel in another type of nuclear reactor. This is correct. So D is correct there. Okay, question 4. It says, one disadvantage of using photovoltaic cells to power a domestic water heater is. Now, a photovoltaic cell is when you take sunlight, so you're taking sunlight and you're converting it in the cell, in the photovoltaic cell, you're converting that into electricity. So it's producing electricity. Often sunlight, when you are looking at these sorts of cells, would just be going from sunlight into heat. I just use that just to heat up the water directly. This is firstly producing the electricity, and then the electricity will be used to heat up the water, change of energy from electrical to heat. So the problem here with this is that you're going to need a large area for photovoltaic cells. The amount of electricity that is actually produced is very low. The other one that you may think of is this one over here, B. The power radiated by the sun varies significantly depending on the weather. This is true. This is definitely true. But you're just looking at light. So even though the sun may not be shining, there may be clouds, you will still get some conversion into your electrical energy. But the main problem with this is that it needs a large surface area. Question 5. Greenhouse gases. What do? Well, let's just go straight to the answer here. They transmit ultraviolet radiation but absorb infrared radiation. Now, infrared radiation is in the form of heat radiation. So we are all producing infrared radiation right now. This is energy that has been given off in the form of heat, and that comes off in this form, infrared. It's longer wave radiation. It's longer than your regular visible light. So if you've got your visible light, and this region is your visible light, let me VL, and if this is going in increasing wavelengths, so this is going in forms of wavelength, you're going to get your infrared on this side. Your infrared is just past the visible light, and your ultraviolet is just on this side. This is your ultraviolet, your UV radiation. This is your IR, your infrared radiation on this side. So what happens is that incoming energy often comes from the sun, comes in that form over there. It gets absorbed by the earth and then gets re-radiated in forms of infrared radiation. And this is what is absorbed by water vapor and so forth to form the greenhouse effect. Question 6. The rate of global warming might be reduced by replacing the use of coal and oil with natural gas. This actually would reduce global warming because these are more efficient and therefore give off less carbon dioxide. A reduction in the Earth's albedo. So this is definitely a possible answer. Reduction in the Earth's albedo. Now, if you reduce the Earth's albedo, it means that you're actually giving off the total scattered power is actually getting less, and so therefore the Earth is absorbing more energy. So that won't help. So that's not good. A reduction in carbon fixation. Carbon fixation is what happens in plants and trees and so forth when it takes in CO2, carbon dioxide, and what it does is it takes it in and it forms carbon compounds like in plants and so forth, and it gives off your O2. So it actually, carbon fixation reduces the amount of carbon dioxide in the air, so that's not correct. And an increase in deforestation. Well, if you have less trees, if you have less forests, then you're going to reduce your carbon fixation, and so you're going to keep more carbon dioxide in the air. So could only be A is correct. The unit of energy density, this is C, joules per kilogram. It's the energy per kilogram that a substance can be used to produce energy. Which of the following is the best estimate of the overall efficiency of a typical coal power station? It's about 30%. Remember we saw before for a gas was about 50%, gas power station. For coal it's about 30%. Question 9. When sunlight is incident on a solar cell, an electrical current is produced. So this was the voltaic cell that we were talking about before. Solar cell, an electric current is produced. This is due to the photoelectric effect. So you have the sunlight coming in. That's in the form of your photons. It's got photons, energy packets, and they cause electrons to jump off, and those electrons form a positive, negative, they form like a little battery, and they form charge to move from one side to the other, and that actually causes your electrical current. Question 10. The power per unit length, P, of an oscillating water column, OWC, is due to the action of a surface wave of amplitude A. Which of the following correctly relates P and A and correctly identifies the nature of the energy of the water column? Well, this formula over here is for wave power. And as you can see with that, you've got a power is proportional to A squared. So the relationship is definitely going to be with the A squared. So it's either going to be these two. Now, what about the nature of the energy of the water column? Well, as we can see, this is a wave. So we're getting, as a wave comes through like this, the particles in the wave are actually moving up and down, At this point over here, that point over there, they have got kinetic energy. And in this point over here, at the highest point and the lowest point, they have got your potential energy. So as with any wave, you're getting a changing from potential to kinetic to potential again. So it would be that over there. So D would be your correct answer. Question 11. The average temperature of the surface of the Sun is about 20 times more than the average surface temperature of the Earth. The average power per unit area radiated by the Earth is P. The average power per unit area radiated by the Sun is. Now, for this, we're going to take this formula over here. Both of these are black body, we can view as black body radiators. So your power, we're looking at the power and temperature is proportional to T to the 4. So if we've got a 20 times amount, we're going to have 20 to the power of 4. So obviously we're going to get 20 times 20 times 20 times 20, which is 160,000. So it would be that over there.